Hi everyone, in this lecture we will see how we can reduce the space and time complexity of this program that we have just done. Now the question is, we cannot reduce the space and time without changing the recurrence, okay? So we need to think, is there any other way to write the power function? Can we break down this function a of n maybe in terms of some other term instead of saying n minus 1? Can we reduce it in terms of f of a comma n by 2, okay? So the answer is yes, it is doable. How? Let me just tell it to you. So I can write something raised to the power n as something raised to the power n by 2 square of this term when n is even, and if n is odd, then I will multiply this result with another a, okay, when n is odd. Okay, so you can easily see, if it is like 2 raised to the power 7, then you can say it is nothing but 2 into 2 raised to the power 7 by 2, that is 3, and square of this term. So effectively what we are doing, we are reducing a problem of size n to a problem of size n by 2. From here we are doing it to n by 4, n by 8, and eventually ending up at 1 or 0. Okay, so effectively if we talk about the number of steps that would be needed, that would be log of n. Okay, so instead of doing n steps, we can actually do this problem in log of n steps. So effectively we are going to use this as our recurrence to solve this problem, and let's see how this is going to work. So maybe I can say int fast power, I get a, I get n. Base case will remain same. If n is 0, I'm going to return 1. Then I'm going to check if n is odd. So if n and 1, that means it's odd number. We are checking the last set bit. Then I can compute the answer for the sub problem. I can say, okay, sub problem is nothing but fast power of a comma n by 2, and I'm also going to square this up. So sub problem square, so that is going to be sub problem into sub problem. Now we already know the squared answer. If n is odd, we are going to multiply the squared answer with a, that is a multiplied by sub problem square, and if n is even, we are simply going to return the sub problem square. That's it. That is our final answer, and we are done. So if I now run this code, cout fast power a comma n and l, and we are going to run this one. So dot slash power, if I give 2 and 10, I get the same answer. If I give 3 and 6, I get the same answer. Okay, so both of them are returning the same answer, but the thing is, here we are taking a less number of steps. For example, I'm computing 2 raised to the power 10. Okay, then it gets broken as 2 into 2 raised to the power 5 and square of this term. So we are only computing this term. So here it gets broken as 2 into 2 raised to the power square and square of this term. Okay, so this is written as 2 into 2 raised to the power sorry, not 2, 2 raised to the power 1 and square of this term, and this is written as 2 into 2 raised to the power 0 and square of this term. Okay, this answer is now what? This answer is 2. This answer is 2 square, that is 4. This is 4 is added here, that is 4 square is 16 into 2, that is 32. And if you put 32 square, something like this, so that would be, I think, 32 into 32, that is uh so this is 2 square 4, sorry, this should be 16. Okay, so this should be 16, and 16 square is 256 into 2 is 512. So we are actually doing 512 into 2, that is 1024. So I hope you're getting this one. We are doing it right, and this is actually perfectly fine. But the idea is, it is going to take log of n steps, both in terms of space and in terms of time. Okay, so that is an optimization, and I hope you really understood this problem. That's it. See you in the next lecture.